Hello. All right. Without further ado, let's get started. We're on chapter 5, risk management methods and tools, of course, is part of the book. And this chapter is risk analysis. So let's get analyzing risks here. All right. All right, there we go. Introduction. Risk analysis is the essence of the risk assessment process. It is the act of making qualified judgments and determining risk levels for an identified risk. Without proper analysis of hazards and their risk, a hazard's risk potential is uncertain and unmanaged. For those hazards and risks that have been identified, an understanding of their potential risk is determined during the risk analysis phase. This chapter will review the concept of analyzing risk and discussing several common methods, as well as provide selected tools and their process steps to the occupational safety and health professional. The risk management process from ISO 31000 risk management standard is shown to the right. So there you go. We're in risk identification. You can see these three are part of risk assessment, identification, analysis, and evaluation. So, well, right now we're on analysis. We did risk identification. So there's where we are in this little stepladder thingy here. I don't know what you call it, but the ISO 31000 Risk Management Standard Series, nationally adopted by the American National Standards Institute in 2011, broadly applied to the management of all types of risk. Within the center of the ISO 31000 risk management process, depicted in Figure 5.1, is risk analysis, the second step of a risk assessment process. The purpose of analyzing a risk is to gain understanding of the risks that are of importance to the organization. Based on the context and scope established by the organization, which we've already talked about, those risks can impact the ability to achieve stated objectives identified. Those risks that can impact the ability to achieve the objectives are identified and recorded. Risk analysis involves the process of determining the nature and level or risk. The results of risk analysis provide the basis for risk evaluation and decision on risk treatment. Risk analysis includes the estimation of risk, which takes the causes and sources of risk into consideration, as well as the severity and likelihood of consequences. We've heard that before, haven't we? Analysis methods can be qualitative, semi-quantitative, and quantitative in nature, which should be determined during establishment of the context, way back when you first start this whole process. Now, quantitative use words like high, medium, low, big, all that type of thing, but they use words. Semi-quantitative describes risk material using rating scales that may be linear or logarithmic, but are not typically based on statistical data. In other words, it's also, you can put numbers like high being 3, low mean low 2, low 1. You can do that too, and that makes it semi-quantitative. You can turn those words into numbers, and so you're using a rating scale. It may linear or logarithmic. Usually it's going to be linear. Not too many of these scales are logarithmic. Quantitative, derived risk rating from statistical data. Now, that's not very common because you got to have a heck of a lot of data to derive statistical data from your history. Risk assessment techniques describes the process of risk analysis with the following sequence of actions: determine controls effectiveness and reliability, analyze nature and magnitude of consequences, analyze likelihood, and measure risk. Determine the control effectiveness and reliability. Determine the effectiveness and reliability of existing controls. What are they, and are they adequate? The following questions should be considered. Do the controls reduce and maintain risk levels to an acceptable level? Now, you know what we're talking about: controls, engineering controls, administrative controls, that type of thing. They tend to, in this book, talk about things without mentioning them. You know what I mean? It's like they want to be in a different world, but they don't, and these worlds overlap a lot. Just the whole risk management and the whole just general safety. So the hazard of the controls are the ones that we talk about anytime we talk about the hierarchy of controls. That's what they're talking about here. Are the controls operating as intended? Excuse me. Can the effectiveness of controls be tested and demonstrated? Is it possible for controls to be intentionally disabled, defeated, bypassed, or minimized? If so, how easy is it? These are things that, as a safety professional, you would be on your mind every time you go through the plant. Are the controls operating as intended? That type of thing. So, the other things on here. Are there escalating factors that can reduce the effectiveness or reliability of controls? Do the controls work in concert or separately? Are they depending on or independent of one another? Analyze the nature and magnitude of consequences. I'll give you an example of controls. One plant in, I think it was in St. Louis, had a light curtain that if the material passed under the light curtain and to be processed in a continuous stream. But one day I went to check the light curtain, stick my fingers in it, and it didn't stop the machine. So what's going on? Oh, they had some stuff that was really thick and was sitting off the light curtain, so they turned it off. Well, so that tells you right there, it can be pretty well easily bypassed. So determine types and severity of consequences. An event may have more than one consequence. The analyst should consider existing controls that have an effect on the consequences, how consequences impact the organization's objectives, immediate impacts and acute consequences, you know what that means right away, long-term impacts and chronic consequences, and secondary consequences or cascading effects on other stakeholders or systems. Analyze likelihood. Likelihood can be determined by three common methods separately or in combination. Historical data review. Again, why don't they just say what they mean here? Historical data review is usually, where do you get your historical data? OSHA logs, workers' compensation records. Okay, both of those. I look at them both, even though that they're very similar. They're almost identical most of the times, but you might get a little in depth from one more than the other. So look at both of those. Predictive analysis and expert opinion. One thing that the workers' comp will give you the dollar amount of that claim. So it might look like a minor incident or accident on the OSHA log, but if it's $30,000, whoa, this is pretty serious here. So predictive analysis, and how do you predict it? And that's just going to be experience mostly. An expert opinion, and you're probably one of the experts that's going to have opinions on it. And again, I've said this many, many times, do not hesitate to bring in outside help if you on something like this, especially if you've not done it before. I've done it, and sometimes you bring them in for one or two times, and then you can go it on your own. So, analyze likelihood, historical data review. Review historical data to extrapolate a probability of occurrence based on past experience. Requires a sufficient number of past occurrences to project a future likelihood. But you know what? If it's happened once before, won't you think it probably could happen again? If it never happened, you think, well, maybe it'll never happen. But if it's happened once or even twice before, to me, maybe we better do something about that. And maybe we should have done it right after it happened too. So predictive analysis, methods such as fault tree analysis and event tree analysis of the system or activity and its failure modes can be used. Operational experience, perhaps from employees with experience in the industry or industry experience in general, perhaps from industry-wide safety organizations or published information can be used. If there is an industry-wide safety organization in your industry, by all means, be part of it and participate in it. Analyze likelihood, expert opinion, brainstorming methods, outside reviews involving knowledgeable stakeholders, consultants, there you go, or other experts. Measure risk. Using the approach decided upon during the establishment of the contest, risk is measured and expressed, frequently using a risk matrix. A comparison of prevention through designs process for analyzing hazards and risks. A comparison of the ISO 31000 risk management process and Z590.3 process is illustrated in the next slide. So you can see that's your one on one side and the other one on the other side, and they're pretty similar. And if I'm going to read any of this, I'm going to put specs on. So you can see that the risk analysis, and that's down in the ANSI model, and this is the 31,000 model. And I don't know why they haven't get together and come up with one, but hey, they never want to make things easy on us, do they? You can see how similar they are. You compare them. This is right out of the book. The steps of risk analysis and ANSI's Z593 are section 0.76. Assess the severity of consequences, determine occurrence probability, define initial risk, select and implement risk reduction and control methods, assess the residual risk. And that's all in figure 3, 5.3 in your book. Assess severity of consequences. Review available information, experience, historical data, expert opinion, and best practices. Here we go again. We're just chewing on the same steak here. Consider frequency and severity of incidents, proper equipment or asset value at risk, degree of business interruption could be a factor too. If it, environmental damage, market share loss. Occurrence probability, kind of the same as likelihood. Consider, they say probability, occurrence, likelihood. I don't know why they don't stick to one nomenclature, but they're all over the place. So you have to know what they're talking about here. So, but they say probability, that's the same as likelihood. Consider frequency and duration of task or event, population exposed, safety, health, and environmental exposures, and dose and exposure assessment. Define initial risk. Using a risk matrix established as part of the risk criteria, the initial risk is determined. Then you prioritize your risk for treatment using the hierarchy of control to determine controls to be used. So you've determined the risk for various, say there's different tasks or operations, however you're doing it, however you've done it when you established your context. And then you're going to prioritize the risk. Okay, the top one's obviously going to get the first treatment. And then you're going to use the hierarchy of controls, get down the hierarchy of controls one at a time and see what you can do to control the risks or hazards. Perform a second risk analysis to determine residual risk level. So in other words, you've done the first one and you've determined the risk level there. So now you're going to, the residual risk is the risk remaining after reduction measures have been taken. So you still have risk. You're not going to eliminate the risk unless, of course, you eliminate the whole operation. The risk-based decision-making model presented in Chapter 2 lays out a sequence of decision-making steps for managing risk. The model, presented in Figure 5.4, also on the next slide, provides a systematic way of the decision-making process using risk-based information to reduce uncertainty and achieve better outcomes. And there's your risk-based decision-making. Identify decision, determine the context, decision makers, stakeholders, options, influential factors, assess risk, determine needs, select risk assessment tools, generate information, make the decision, evaluate information, assess options, select option based on risk, and monitor effectiveness. Evaluate results, assess impact, make refinements, communicate results. Now, it's all good to have these all written out, but you know what? This is kind of something you're going to do. Just going to do. I mean, it's kind of without even going through steps writing it down, but they're just kind of formalizing things here. Hazard and risk analysis methods. The process of analyzing risk can be performed using a variety of methods, some of which are covered in this chapter. ISO 31010 lists a number of techniques ranging in application, complexity, and ease of use. Certain methods are specially designed to analyze causes or triggers, control measures, consequence and likelihood levels, or all of these areas as shown in Figure 5.5. Next slide. Here we go. So you're going to analyze risk. Here's your things up here in the top. And then cause analysis, likelihood and consequence analysis, controls analysis. And these are all in the book. You can look at them there. We'll cover some of them here, but I'm not going to go all of those in detail. Just got a book for. Right? Oops. Want to do that. All right. Let me make sure I'm in the right one here. Yeah, I am. Okay. Conducting hazard risk analysis. Assessing risk presented by identified hazards is key to risk management and a critical function within an operational risk management system. The analysis and assessment of risk assessment provides decision makers a better understanding of risks that could impact the organization's business objective and the efficacy of existing controls so that the organization can manage operational risks. Risk analysis and assessment provides risk-based information to decision makers so that the most appropriate risk treatments can be selected to achieve an acceptable risk level in the organization. Hazard analysis is a process that commences with the identification of a hazard or hazards and proceeds into an estimate of the severity of harm or damage that could result if the potential of an incident or exposure occurs. Risk analysis consists of determining the consequences and their probabilities for identifying risk events, taking into account the presence or not and the effectiveness of any existing controls. The consequences and their probabilities are then combined to determine a level of risk. So the hazard analysis, hazards identified, hazards, exposures, and controls, determine severity of consequences. That's your hazard analysis. Now the risk analysis does the same thing, but carries it 2 steps further. Determine likelihood of occurrence and estimate the risk level. Conducting hazard risk analysis. There is a list of hazard risk analysis methods in Table 5.1, pages 113 and 114. Note that many of them are the same as the hazard identification method shown in Chapter 4, Table 4.2. Conducting hazard risk analysis, hazard analysis, again, more of that. Develop plan. Following established context, define scope, purpose, personnel, resources, budget, timeline, and other elements needed for the effort. Define responsibilities. The roles and responsibilities, interrelationships, and lines of communication within the organization and affected stakeholders should be defined. Analyze hazards, exposures, and potential failure modes. These are all analyzed in a structured way using the selected risk analysis method. The analyst should determine how and why hazard exposures, failures might occur, conditions and causal factors that can lead to exposures or failures, frequency and duration of the task, event, or condition, affected parties, property, or assets exposed to the hazard or potential failures. Analyzing existing controls. The efficacy of existing controls are analyzed to determine levels of effectiveness and reliability. A physical review of existing controls should be performed to test and verify that their application and protection are correct. A physical review. And I want to tell you, go out and look at them, of course, but work or try them. For instance, e-stops. You got a machine with e-stops. Every quarter, I would suggest somebody's got to go out there and hit that e-stop, make sure that thing works. Because if it doesn't, it could be disastrous. That's what the e-stops are in emergency. In emergency, you need to stop that machine now. And if you have e-stops that don't work, they will not stop that machine now. So that person's going to get much more severely injured. Analyze the ability to defeat, bypass, or minimize existing controls and the ease of doing so. So e-stops are somewhat of a control, but they're not a control in the way to stop a hazard rather, or an injury, usually. But they are there so to greatly reduce the seriousness of the injury. I think I mentioned it in the plant in St. Louis, one of the plants there. Before we bought this company out, they would put they had counter rolls at the end of the line. Counter rolls are heavy rolls that usually have a pattern on them. They emboss it into the product. It's polyester going through it. And they were starting it up. Usually you start up, you fold the edge of the thing into a point, and you stick it in with a stick in between these two rolls. Well, they didn't have stick. What happened to the stick? I don't know. So the guy uses fingers to put it in there. He puts his finger in there, and his fingers get caught. So what's your natural reaction? Grab the other one. Both his hands get caught, and they get pulled into this thing. There's no e-stop. He's shouting, but it's kind of noisy. It pushes all this stuff up in both his arms and blows up. He uses both his arms entirely. Now, with just simply an e-stop there that he maybe couldn't even put with his mouth, or when his first hand got caught, just pulled that e-stop with another hand caught. He might have lost a couple fingers, but not both his arms. So that's a very drastic example, but it's a true one of e-stops. They're not being a control per se, because they don't really stop it from happening, but they sure do make a big difference if somebody does get caught in a piece of equipment. They can stop it right now. E-stop should be everywhere you're at on the machine. Should be able to stop it just about. So, conducting hazard risk analysis. Here we go again. Analyze severity of consequences. Credible scenarios and consequences are identified and listed. The greatest consequences are the first selected for analysis. At this point, the hazard analysis has been completed. Now, we talked about that little chart that had the 2 on the top and the 4 on the bottom, that little graph there. At this point, the hazard analysis is completed. Now, the following steps constitute a risk analysis. Analyze and estimate likelihood. This requires a review of available information, input from knowledgeable stakeholders, experts, and empirical or statistical data if available. Okay, we talked about likelihood. Estimate risk level. Once severity and likelihood are estimated, they are combined according to the selected risk scoring formula to derive a risk score. This is usually done using a risk matrix. Hazard and risk analyses are usually performed at the task or job level. Some may cover a process or operation, but usually you want to do this at one particular job or task. Could you cover an entire process? Yeah, you could, but it gets pretty complex. Usually it's just one operation, one piece of equipment. The rest of Chapter 5, Risk Management Tools, will be in a separate presentation. I cut these down into smaller units, make it easier for you to plan your time as well. And who wants to listen to me gab for 2 hours? So that's it for the first part of this chapter, and we'll catch up with the second part and when the Spirit moves me. Be safe.